Good morning once again, and I am very happy to introduce Dr. Pandichelvam R. He's a senior scientist, agriculture engineering at ICR, Indian Agricultural Research Institute. He completed his BTech in agriculture engineering in 2010 and MTech in agriculture processing and food engineering in 2012, and PhD also from Tamil Nadu Agriculture University, Coimbatore. And he joined the ICR in 2016 as a scientist at ICR Central Plantation Crops Research Institute, Kasaragod and Kerala. And he has made a significant contribution to the development of post-harvest technologies, including machines for the tender coconut processing, value-added coconut products, and benefiting several entrepreneurs. And he has published over 100 research papers and review articles and authored 9 books and 87 book chapters, and he serves on the editorial board of several international journals. Moreover, he is a recipient of several prestigious awards, including NAS Young Scientist Award, NAS Associate, and ISAE Distinguished Service Award. And recently, he received a ICR Rashtriya Krishi Vigyan Puruskar 2025. And he also listed among the world top 2% of the scientists by Stanford University and elsewhere in 2023 and 24 and 25. And also he has a high citation index around 62 and a high 10 index around 232 and total number of citations around 13,118. Dr. Pandichelvam, you could continue your lecture.
Thank you, sir. Thank you, Selva sir, for the nice introductions and for giving me the opportunity to deliver a lecture on ozone-based post-harvest intervention for shelf-life extension and safety of protected horticulture produce. So friends, next 1 hour, I would like to discuss about what is ozone, why we have to use ozone, because there are different preservation technologies available. So what is the advantages of ozone as compared to other technologies, and what is the disadvantage in using ozone, and what are the industries now commercially they are using ozone for preservation of fruits and vegetables. So all this content I will explain in next 1 hour. So this is the outline of my presentation. So first I am introducing about ozone and ozone generation method and advantage and disadvantages of ozone. And ozone is applied for different aspect. And ozone is not only useful for decontamination of fruits and vegetables, it is also useful for pesticide decontamination, starch modification, stored product insect control, and aflatoxin control from grains and vegetable producers. So ozone is nothing but it is a triatomic form of oxygen. So oxygen is O2 molecule, and here ozone is O3 molecule. Okay, and even 1997, our US FTA, they agreed or they given status as a GRAS, generally recognized as safe. If a food product is treated with ozone, it can be called as a generally recognized as safe treatment. Okay. So once in 1997, this ozone received US FTA GRAS status, then there are many research on application of ozone for preservation or shelf-life extension of fruits and vegetables. In early 2000s, the most of the research work they have conducted, how effective ozone is to control gram-positive bacteria, gram-negative bacteria, how it is effective to remove these pesticide residues. So there are different kind of research work between 2000 to 2020, and this ozone was implemented at industry scale after 2020 or after this corona. Okay, and one of the advantage in using ozone is you are producing an organic produce, and if it is treated with ozone, it can be classified under organic. But suppose you are producing the fruits and vegetables under organic condition, but you treated with chemicals, it can't be called as a organic produce. But if you treat with ozone, then it can be called as a organic producers. So ozone generally we can produce by 2 methods. One is called corona discharge method and another one is UV based method. These 2 methods are very common, and out of these 2, the industries now they are using corona discharge method. And all of you, we have aware that ozone layer, it was located in our stratosphere, in the Earth atmosphere. Okay, so how naturally ozone is formed in stratosphere? The scientific reason is when the oxygen is exposed to the sun UV rays, immediately this oxygen molecule will break down into singlet oxygen. This singlet oxygen will combine into O2 molecule, and finally it will form O3 or ozone molecule. Okay, and one more method is called corona discharge method. So if the oxygen molecule is exposed in a heavy thunderstorm, during rainy season there is a heavy thunderstorm, right? So at the time, if the oxygen molecule is exposed into the heavy thunderstorm, so due to this high energy, the oxygen molecule will split into singlet oxygen. That singlet oxygen will join with O2 molecule and it will form ozone. So just this is a short clips about how ozone is formed in the stratosphere. The same mechanism is applied to produce the ozone by using this corona discharge method. So here, due to this high voltage or due to this UV rays, this oxygen molecule will split out into the singlet oxygen. That singlet oxygen will combine into the O2 molecule and it is forming ozone. So here, in case of corona discharge method, to produce ozone, we have to pass this oxygen molecule in high voltage, nearly 6,000 to 20,000 volt. So we have to pass the oxygen molecule in between the electrode. That electrode will supply high voltage, that is around 6,000 to 20,000 volt. So if the oxygen molecule is subjected to high voltage, then as I mentioned, that oxygen molecule will split it into the nascent or singlet oxygen molecule, then it is forming ozone. So corona discharge method is most popular as compared to UV light. The reason is the yield, the final yield or the final ozone outcome is more in terms of corona discharge method as compared to this UV light method. Okay, so that's why most of the industries they are using corona discharge method due to its high effectiveness for producing ozone. Okay, so now you might be seen ozone is not only useful for washing of fruits and vegetables. Now you might be purchased any water bottles. So you might be seen in the label, the water was treated with ozone UV, right? So ozone was initially used to treat the water. Then slowly it will enter into the fruits and vegetable industry. And now many industries, they are using ozone for washing of these producers, as well as many cold storage rooms. They are using this ozone gas for disinfection purpose. So this is the advantage of using ozone as compared to other methods. So generally for preservation of fruits and vegetables, we are using either thermal based method, or for example fruits and vegetable washing. Now industries are commonly they are using chlorinated water. Okay, so they will add chlorine in the water at the concentration of 50 to 200 ppm in the range, and after adding this chlorine in the water, then they are dipping the producers like any fruits and vegetables in the chlorinated water for 5 to 10 minutes. Okay, then again it will go for one more washing, then it will go for subjection to the processing. Okay, but in case of chlorine, the disadvantage is the chlorine residue, it will deposit on the surface of fruits and vegetables. Okay, so that's why ozone is the best alternative for this chlorinated water, because the advantage with ozone is ozone, due to this high oxidation potential, the ozone will be auto degraded into the oxygen. Okay, so once the ozone is auto degraded into oxygen, oxygen is like a healthy environmental gas, so it does not impact any negative to the atmosphere, right? So once you produce the ozone, you keep it for 20 or 25 minutes, again it will be converted into oxygen, because ozone is not a stable molecule. Ozone is a highly unstable molecule because of this oxidation potential. Okay, so that's why once your producers, any fruits and vegetables are treated with ozone, again this ozone will be converted into oxygen. So it does not create any toxic gases or we are not leaving any toxic gases to the environment. Okay, so this is the main advantage in ozone as compared to other chemicals. Okay, so ozone is a non-thermal technology. If you are treating with ozone, ozone does not generate any temperature during the treatment time. Okay, and ozone, there are many studies, they proven that ozone increases shelf life of many fruits and vegetables in 2 or 3 fold as compared to the uncontrolled or untreated producers. Okay, in later slide, I will give more details. Then initially ozone was used for water as well as wastewater treatment. And ozone, nowadays the research is exploring how ozone is effective to remove the ethylene or how to slow down the ripening by applying this ozone gas. Okay, so as I mentioned, ozone gas is also useful as a disinfection agent in the storage, cold storage unit. So, but in case due to ethylene, ethylene is the hormone. It will speed up the ripening of any fruits and vegetables. So even if your cold storage room treated with ozone, it has also capacity to destroy the ethylene. Okay, so that the ripening can be slowed down. The shelf life of fruits and vegetables, it can be enhanced. Okay. So in 1997 itself, ozone has got approval from US FDA, and it is environmental friendly because due to unstable nature, ozone will be converted into oxygen. So it does not produce any toxic gases after the treatment. And ozone is much more powerful than chlorine. Suppose you want to treat the chlorinated water for 5 to 10 minutes. For in case of ozone, hardly 2 to 3 minutes treatment is sufficient to achieve 5 log reduction of microorganism. Okay. So this is a short video is highlighting about how ozone is initially introduced in the wastewater treatment. And you might be knowing that initially wastewater will be treated with free filters to remove the heavy metals or large size particles. Then after that, the ozone, so that wastewater will be treated with ozone. Here you might be closely observe this video. So here the oxygen molecule is fitted into the singlet oxygen. It is producing ozone due to corona discharge method. So this is the most important thing. See how ozone is eliminating the toxic compound. The ozone is destroying the toxic compound. So it will destroy the complex molecule and make it into the simplex molecule. Okay. So after ozone treatment, the wastewater will be subjected to this activated carbon filter, and finally it will go to the recycle purpose. Okay. So initially the ozone, so once in 1997, ozone got approval GRAS status. The research, yearly research was focused on application of ozone in water industries. Okay. Even now you might be observed, many of the swimming pools, they are having the filters. That is nothing but that is a ozonated filters. Okay. So the swimming pool waters, it can be recycled or it can be treated with ozone for this recycle purpose. Okay. And this is a setup for treating any fruits and vegetables. So if you want to establish this ozone setup, we need 5 equipment, these 5 major equipments. So one is oxygen cylinder or oxygen concentrator. So in order to produce ozone, we need oxygen cylinder or oxygen concentrator. Yes, of course, we can use this atmospheric air, but the problem is ozone outlet. Because our atmospheric air, mostly it contains nitrogen. Okay. So instead of passing atmospheric air, if you pass oxygen, then you will get more output of ozone, and you will get more effectiveness for this ozone. So we need oxygen cylinder or oxygen concentrator to produce ozone. And the second equipment is ozone generator. So as I mentioned, there are 2 methods to produce ozone. One is corona discharge method and another one is UV based methods. But most of the industries, they are preferred to use corona discharge method due to this high effectiveness. So we need oxygen cylinder and ozone generator. This is working based on corona discharge method. Then treatment chamber. Of course, we need a treatment chamber to treat our fruits and vegetables. Then fourth one is ozone analyzer or ozone monitor. This ozone analyzer is required only for lab scale research. If you are going for industry scale research, this ozone monitor may not be required. Okay. And if you feel that you produce much more or excess ozone than your recruitment, then we can destroy the excess ozone by ozone destructor, because ozone also toxic gases if it is there in the O3 form. Okay. So if you feel that you need only 10 ppm, but you produce 20 ppm of ozone, we can destroy by using this ozone destructor. Okay. So these 5 equipment we need for our lab scale research or pilot scale research. Okay. And the cost of this, all these 5 equipment is approximately 15 lakhs. Okay. So we need these 5 and the cost is around 15 lakhs. This is a industry scale setup for treatment of ozone-based chamber. So one of the most important observation here is ozone is highly corrosive in nature. So the ozone passing gas, that tube lines as well as ozone treatment chamber, it should be made out of stainless steel. It should not be made out of rubber or PVC, because ozone is highly corrosive in nature due to this oxidation potential. So for treatment chamber, we have to fabricate the fruits and vegetables treatment chamber by using stainless steel. Okay. And this is a work conducted in Australia, and this work was published in India. Not published, it was highlighted in the newspaper. So treating the mangoes for only 10 minutes, it will extend the shelf life for 2 weeks. Okay. So treating the mangoes only for 10 minutes is extending the shelf life for 2 weeks. Then you can imagine how ozone is more effective. So we are treating only 10 minutes and it is possible to extend up to 2 weeks, higher than compared to uncontrolled or untreated one. Okay. And this is the research work was conducted by my student. So the title of the research work is Effect of Ozone Treatment or Ozone Treatment for Improving the Quality Parameters and the Surface Decontamination of these tomatoes. Okay. So here what we have done, here we have designed the ozone treatment chamber. Then we have optimized this ozone concentration and exposure time. Then after treatment with ozone, we have analyzed the shelf life of tomato. So this is a procedure we have followed during the experiment. So initially we have taken this raw tomato and it was subjected to cleaning, grading and washing. Then after washing, it was just dried, air drying at room temperature. Then we have analyzed these quality parameters before the treatment. Then it was subjected to this ozone treatment at a different concentration and exposure time. Then after a treatment, we have analyzed the quality. So ozone, the problem is, yes, of course, it is destroying the microorganism. At the same time, if you are passing higher ozone or high concentration ozone, it have negative impact on the nutrient content. Because here, as I mentioned, tomato is rich in lycopene. If you pass this tomato under high ozone concentration, even this lycopene can degrade. That's why each and every product based on this bioactive compound present in the product, we have to optimize this ozone concentration and the exposure time. So based on my literature review, I observed that most of the studies, they have conducted up to 10 ppm for surface cleaning of fruits and vegetables. Okay. So most of the studies, they have highlighted that less than 10 ppm of ozone concentration is sufficient to reach 3 to 4 log reduction of microorganism. Okay. So in this study, after ozone treatment, we have analyzed the quality. Then we have conducted the sensory as well as storage studies. So this is the independent and dependent parameters for our study. So here we have taken independent parameters, 3 parameters we have taken. One is ozone concentration and treatment temperature and exposure time. So treatment temperature. So as I mentioned, ozone stability. So ozone stability is most important factor. It depends on the atmospheric or temperature. Okay. Suppose you are releasing the ozone gas in the atmosphere. Now the atmospheric temperature is 30 degrees centigrade. Okay. Your ozone will be converted into oxygen within 10 minutes. You imagine that your atmospheric temperature is 20 degrees centigrade. You are passing the ozone gas at 20 degrees centigrade. The stability of the ozone gas is much more higher at lower temperature. Okay. So as I mentioned, in 30-degree temperature, within 10 minutes, the ozone will be converted into oxygen. But if you are passing the ozone gas at lower atmospheric temperature, 20 degrees centigrade or 10 degrees centigrade, the degradation rate of ozone is lower. So it will take 20 to 30 minutes to convert ozone into oxygen. Okay. That's why always we are recommending that the ozone treatment should be done under lower temperature in order to get higher effectiveness. Okay. So after a treatment, we have analyzed all these dependent parameters like moisture content, weight loss, water activity, color, firmness, ascorbic acid, beta carotene, lycopene, TSS. Okay. So all these biochemical parameters we have measured after this ozone treatment. And this is a treatment chamber we have developed for treating this ozone. Okay. And this treatment chamber we can treat any kind of solid food producers, any kind of fruits and vegetables. Okay. So here the advantage is when you are passing the ozone, the inside the treatment chamber, we can change the temperature. We can maintain 30, 20 or 10 degrees centigrade. Okay. As I mentioned, ozone is more effective at 10-degree temperature. Okay. So along with this treatment chamber, we have attached this refrigeration unit. That refrigeration unit will help us to maintain the lower temperature. Okay. So we have placed the tomato. So these are our variables. So after conducting different kind of treatments, we optimized that 30% ozone concentration. 30% means here 1.5 grams per hour. So 30% ozone concentration, 10-degree treatment temperature at the exposure time of 11.7 minutes is given very good result in terms of highest microbial load reduction, in terms of retention of this bioactive compound present in the tomato. So based on these parameters, we have optimized this condition. So after a ozone treatment, we have conducted the shelf-life studies. Okay, after a ozone treatment, how many days it extends the shelf-life of this tomato? So during the shelf-life studies, we packed the tomato under different packaging material, perforated polypropylene pouches and perforated PET boxes, and we kept it up to 21 days. Okay, and we have analyzed the quality at every 7 days interval. So also we have conducted the experiment at a different storage temperature. So after a ozone treatment, one batch we kept it under refrigerated storage, one batch we kept it under atmospheric storage. Okay. So finally we found that ozone concentration of 30%, that means 1.5 grams per hour, 10-degree temperature, and 11.6 or 7 minute exposure time. It will extend the shelf life up to 21 days. Okay. But in case of untreated tomato, you might be observed hardly 7 to 10 days it will spoil. Okay. So this ozone treatment, it will extend double than the untreated one. Okay. And the research result we have published in the journal Ozone Science and Engineering. So if you want more information, you can refer our article. So this video will highlight about generally how producers are treated with ozone. Ozone can be treated with two forms. One is gas form and water form. Okay. So this video is highlight about how ozone is useful to treat the produce in the water form. So this is the ozone. No, this is not ozone generator. This top one is the ozone generator. This is the ozone generator. So ozone gas will be dissolved in the water. So here they are spraying the ozonated water. So we can use ozone in the gaseous form or in the water form. So this is one more work, one more video. This also conducted in India. This is called ozone turbulence washer. Here the ozone gas will be dissolved in the water. So here the ozone gas is passing inside the water. That's why it started generating the bubbles. So here they are washing the tomatoes with ozonated water. So first it was subjected to bubble washer, then it will be subjected to this ozonated water. So by treating or washing the fruits and vegetables with ozonated water, we are not only decontaminating bacteria, we are also removing pesticide residues. And even it was proved that ozone is very effective against virus. So after COVID-19, there are many research work how ozone is effective against this virus. That also I am explaining in the later part of this presentation. So ozone is effective to remove the bacteria, to decontaminate this bacteria, virus, as well as pesticide residue. So it will also remove this pesticide residue present in the surface of fruits and vegetables. Okay. So these are the general parameters we have to consider before treating with ozone. Okay. So as I mentioned, physical state of ozone. The ozone, it can be applied in water form or gas form. Okay. But if you want to treat any grains, you have to go for gaseous form. You want to treat with any fruits and vegetables, you can go for water form. Okay. So according to your commodities, we can decide whether you can go for gaseous form or we can go for water form of ozone. Okay. And second foremost important factor is concentration. So if you applied higher concentration, definitely it is effective. But the problem is, if you go for higher concentration, it will negatively affect the bioactive compound present in the fruits and vegetables. So it is always better that we can treat our produce under low concentration of ozone. Even it will take longer treatment time. If you pass low ozone concentration, it will take longer treatment time. But it is always better to treat with lower ozone concentration, less than 10 ppm. Okay. Then flow rate. So if you are passing this ozone gas, the flow rate is most important factor. Okay, it should not be too much high flow rate. If you are passing heavy or high flow rate, then your produce does not have sufficient time to interact with ozone. Okay, so that's why always the flow rate will become 1.5 to 2 liter per minute. Okay? And another important parameter is temperature and RH. Okay. So if you are treating with any produce with ozone gas, so as I mentioned in our research, we have conducted, the ozone treatment was conducted with different treatment temperature, 10 degree Celsius, 20 degrees Celsius and 30 degrees Celsius. And we found that 10 degrees Celsius based ozone treatment is very effective because the ozone stability is high at lower temperature. Okay. So the treatment temperature, when you are applying the ozone gas, at the time, what is the condition or what is the temperature and relative humidity present inside the treatment chamber? That is most important. Okay. So we have to maintain low temperature and high relative humidity in order to achieve more effectiveness or more efficacy of this ozone gas. And these are the extrinsic parameters. And this next one is intrinsic parameters. So we have to also consider this intrinsic parameter of the producers. So suppose ozone is not only useful to treat whole fruits and vegetables, it is also useful to treat fruit juices. Okay. So if you want to treat any fruit juices, if the fruit juices have low pH value, the ozone is more effective. The concern is the stability, again the stability or the conversion ratio between ozone to oxygen is very slow. If the produce or fruit juices have low pH, the conversion rate or stability of the ozone is very high. Okay. So the pH of the fruit producers is also important, and the organic matter present in the fruit juice. Suppose you are treating filtered orange juice and unfiltered orange juice. Okay. So the filtered orange juice have less organic matter. If you are passing the ozone gas, it will be more effective. Even a study was conducted with the orange juice, filtered orange juice and unfiltered orange juice. They have find out that almost 20 ppm of ozone for 4-minute time is sufficient to kill 5 log reduction in filtered orange juice. But the unfiltered orange juice, it have higher organic matter. It need 3 times higher exposure time or higher treatment time. Okay. So we have to always go for filtered juices for treating with this ozone. It will be more effective because unfiltered juice, it have more organic matter. So organic matter means it will again consume the ozone. So then ozone will not kill the microorganism. Okay. And moisture content of the food product. If the food product is have higher moisture, we can go for lower ozone concentration. If the food product have lower moisture, for example, you want to treat the fruits and vegetables, you can apply only 10 ppm ozone concentration. But if you want to treat grains, then you have to go for higher ozone concentration because grains have lower moisture, almost 10 to 12% moisture. Okay. So if the food product have lower moisture, we have to go for higher ozone concentration. And this is a slide explaining about what is the mode of action, how ozone is killing this bacteria or this virus. Okay. So once the ozone is react or contact with this bacterial cell wall, due to this oxidative nature, it start creating some minor or tiny holes on the surface of this bacterial cell wall. Okay. So once the ozone is reacting with the bacterial cell wall, it is creating the so many tiny holes on the surface of this bacterial cell wall. Okay. So finally, the cell wall will be collapsed and the DNA, this RNA part will be damaged. Then it leads to the death of the cell or death of this microorganism. Okay. So this reaction is called oxidative burst. Okay. So we have conducted one literature review regarding how ozone is effective for these fruits and vegetables and what is the concentration they are using. So from this table, you can observe that most of the treatment less than 10 ppm of ozone concentration is sufficient to kill minimum 3 to 5 log reduction of microorganism. Okay. So that's what I am mentioning, that if you want to treat any fruits and vegetable with ozone, you can go for ozonated water with the concentration of less than 10 ppm. It may be 8 ppm or 9 ppm. Okay. With the treatment time of hardly, you might be seen 2 to 5 minutes is more than sufficient, but some producers, it may need more time because it depends on this microbial load. Suppose your producers have contaminated heavily with more microbial load, you have to treat more time. you need more treatment time. If your producers have only less microbial load, within 5 minutes you can destroy all the microorganism. Okay, so that's why you might be seeing the study was conducted for mangoes within 10 minutes, and it is increasing shelf life for 2 times. Okay, so for fruits and vegetables, the recommended or most effective ozone concentration is less than 10 ppm at the treatment time of 2 to 5 minutes. And this is a video this highlighting about how ozone is more effective for leafy vegetables. Because leafy vegetable, the problem is within 1 day, it will become spoil. If you might be seen in the market, most of the leafy vegetable, if they are keeping outside for 1 day, so it will spoil. But you might be surprised after seeing this video. See the left side image, it was treated with ozone. The right side was treated with RO water. Okay. So you see this observation or physiological changes after treating with ozone as well as RO water. Okay. So within 6 hours, even if the producers are leafy vegetable treated with RO water, it will become very dull, it will shrinkage. So from this video, you can clearly understand that even 0.2 ppm of ozone is more effective for leafy vegetables. So even if the leafy vegetable treated with RO water, within 6 hours it got spoiled. But you might be seen in the ozonated water, the produce leafy vegetable treated under ozonated water, it extends the shelf life or freshness, or it will maintaining the freshness up to 13 hours in the atmospheric temperature. So after COVID-19, there are many industries, they started producing
से मार्केट तक और मार्केट से आपके घरों तक सब्जियां और फलों को न जाने कितने केमिकल्स और बैक्टीरिया का सामना करना पड़ता है और इन्हें सिर्फ बेकिंग पाउडर या नमक वाले पानी से धोना काफी नहीं होता। आपकी इसी जरूरत को पूरा करने के लिए सेलो लेकर आया है आधुनिक ओजोन टेक्नोलॉजी वाला वेजिटेबल एंड फ्रूट क्लीनर, जो न कि सिर्फ फलों और सब्जियों को जानलेवा बैक्टीरिया वायरस से बचाता है, बल्कि उन पर लगे केमिकल्स, पेस्टिसाइड्स और आर्टिफिशियल प्रिजर्वेटिव्स का भी खात्मा करता है और उन्हें लंबे समय तक फ्रेश रखता है। इसमें फल और सब्जियों के अलावा आप फिश, मीट, दाल और चावल में छुपे हुए बैक्टीरिया एंड पेस्टिसाइड्स को भी आसानी से साफ कर सकते हैं। यहाँ तक कि आपकी शिशु की दूध की बॉटल्स और किचन की छोटी छोटी रोजमर्रा की चीजों को भी स्टेरिलाइज कर सकते हैं। जितनी अट्रैक्टिव सेलो क्लीनर की डिजाइन है, उतना ही आसान है उसे इस्तेमाल करना। इसके पावर पिन को इलेक्ट्रिक सॉकेट में कनेक्ट कीजिए, फिर कंटेनर में मार्केट से लाए हुए फलों और सब्जियों को रखिए। ध्यान रखिए कि ड्रेनेज पाइप अपनी जगह पर लगा हो, फिर उसमें पानी डालिए और लीड लगाकर उसे बंद करें। ऑन का बटन दबाइए और आपकी जरूरत के अनुसार प्री सेट फंक्शन टाइमर चूज करें और फिर से ऑन बटन प्रेस कीजिए। फिर सेलो फ्रूट एंड वेजिटेबल क्लीनर की शक्तिशाली ओजोन टेक्नोलॉजी का कमाल देखिए। देखते ही देखते ये सारे फलों और सब्जियों को क्लीन, फ्रेश और केमिकल फ्री बना देगा। टाइमर खत्म होते ही आप कंटेनर का गंदा पानी ड्रेनेज पाइप के द्वारा बाहर निकालें और अपने फलों और सब्जियों को साफ पानी से धोकर इस्तेमाल करें। सेलो फ्रूट एंड वेजिटेबल क्लीनर को साफ करना भी बड़ा ही आसान है। इस्तेमाल करने पर आपको बस साफ पानी से कंटेनर धोकर पाइप से उस पानी को ड्रेन करना है। ये सिर्फ इजी टू क्लीन नहीं, बल्कि मेंटेनेंस फ्री और एनर्जी एफिशिएंट भी है और इसे आप बिना किसी तकलीफ के सालों तक इस्तेमाल कर सकते हैं। मार्केट में आपको कई वेजिटेबल एंड फ्रूट प्यूरिफायर मिलेंगे, लेकिन सेलो आपकी सुरक्षा को समझता है और इसीलिए हमारे प्रोडक्ट को उसी तरह से डिजाइन किया है। 10 लीटर के स्पेस के साथ आपके फल और सब्जियों को एक साथ ज्यादा मात्रा में प्यूरिफाई कर सकता है। इसे और भी खास बनाता है इसका ये बंद आकार, क्योंकि कहा जाता है कि ओजोन को ज्यादा मात्रा में इनहेल करना हानिकारक हो सकता है। सेलो फ्रूट्स एंड वेजिटेबल क्लीनर का 400 मिलीग्राम पर आवर वाला इनबिल्ट ओजोन आउटपुट बिल्कुल सेंटर में प्लेस्ड है, जिसकी वजह से ये बाकी पाइप गैस प्रोडक्ट से ज्यादा बेहतर और असरदार है। इस पानी में डाले हुए इंक जैसे केमिकल को ही देखिए, कितनी आसानी से ये इम्प्योरिटीज को खत्म कर देता है। ओजोन डिसइंफेक्टेंट टेक्नोलॉजी पूरी दुनिया में बड़ी फूड एंड बेवरेजेस कंपनीज में यूज की जाती है। सेलो इस टेक्नोलॉजी को आपके घर में उपलब्ध कराना चाहता है ताकि हर परिवार स्वस्थ, तंदुरुस्त और सुरक्षित रहे। तो अब इंतजार किस बात का है? आज ही किफायती दाम में सेलो वेजिटेबल एंड फ्रूट क्लीनर को अपने परिवार का हिस्सा बनाइए और अपने परिवार को सिक्योर कीजिए।
So after COVID-19, we are mostly worried about virus and virus disinfection. Okay. So after COVID-19, there are many industries, Faraday ozone, cello. There are many industries, they fabricated this small ozone-based cleaning system for household purpose or for household purpose. And they have claimed that even your grains and fruits and vegetables, if it is washed with this ozone washing system, it will be more effective. Okay. So as I mentioned, my first part was covered with how ozone is effective against to kill this bacteria. Next part, I am explaining about how ozone is more effective to remove this pesticide residue. Because nowadays you might be seeing any of the fruits and vegetables you are purchasing from the market, it was sprayed with pesticide or fungicide. Okay. So now the concern is how to remove it. So in home, just we are washing with normal tap water. Okay. But now washing with normal tap water is not sufficient. So that's why even many of the research work they have conducted with ozone to understand the effectiveness against this pesticide residues. And this is a survey conducted in India. So here they are highlighting that not only fruits and vegetables, you might be taken soft drinks. Most of the soft drinks also it have pesticide residue. Okay. So even you might be seeing most of the soft drinks, it have the pesticide residue from 5 to 30%. Okay. And in case of fruits and vegetables, you take brinjal, it have 860% above the legal limit of this pesticide residue. So likewise, there are many fruits and vegetables, it have pesticide residue. Even not only fruits and vegetables, you take cereals, grains, spices. So many of the dry producers also it was having this pesticide residue. At least fruits and vegetables we are washing and after that we are consuming. But in case of spices, immediately after harvesting it will go for drying, then it will go for powdering. Okay, for example, you have taken chili powder, pepper powder. Okay, so after harvesting, it will go for drying, then it will be subjected to powdering. So most of this pesticide residue, even it was found in these spices. Okay. So again, here the study was conducted with gaseous ozone as well as water form of ozone. Okay. And some studies, they are proven that in case of water form of ozone, it is a micro bubbles, it is a nano bubbles. Even nano bubble form of ozonated water is more effective than this micro bubbles due to this high surface area. Okay, so there are large studies they conducted with this water form of ozone. This water may be nano form or micro form. Okay, and it was found that ozone is very effective. Minimum 70% of the pesticide residue it will remove. Once your producers, it will be subjected to washing with this ozonated water, we can able to remove 70%, minimum 70% of this pesticide residue. But here the concern is, ozone is effective for surface treatment. If the pesticide residue is present inside your fruits and vegetables, inside the skin of your fruits and vegetables. It can't remove. Okay, it will not eliminate 100%. Okay, so ozone is very effective only for this surface treatment. And not only ozone treatment will be useful for bacteria elimination or pesticide residue elimination. Even studies they are doing or conducting how ozone is effective to for starch modification. Okay, industries they are using these chemicals for starch modification. This starch you might be knowing starch will be widely useful for say packaging material. For developing this biodegradable packaging material, now we are using starch, and the starch is useful for the bakery industries, and the starch will be useful as a thickening agent, emulsifier, stabilizer. Okay, so nowadays, starch is the common product for the most of the food industry. Okay, but the problem is modification because native starch, whatever starch we are extracting from this potato or rice, we can't directly use it. It has to be modified in order to get better functional properties. Okay? So, in order to get or in order to improve the functional properties, now industry they are using chemicals to treat the starch particles. But after this ozone introduction, even many studies have proved that ozone is very effective for the starch modification. It will improve the clarity of the starch. It improves the whiteness index of the starch molecules. It improves the pasting property of the starch molecule. Okay. So you see this video, how ozone is effective to improve the functional properties of the starch molecule. This work was conducted in the Brazil. This is a treatment setup, the same as I explained before. Okay. So this is a 0-minute untreated starch, 15 minutes ozone treated starch. This one is 0-minute, that means control one. This was not treated with starch. You see, this is very thick. The pasting property is very low. And you see this color. It is dull in color. It is a creamy white in color. See, this is a 15 minutes treated starch molecule. You see how the brightness. So it will improve the clarity of the starch molecule. See, this is very soft. So it will improve the pasting property of the starch. This was treated with 13 minutes with ozone. You see, this is very, very soft. This is very bright white in color. Okay, so apart from bacterial decontamination, pesticide residue elimination, ozone is also useful for starch modification. Okay. So this is a study highlighting about how ozone is effective for the starch modification. Ozone was found that it is effective against different kind of starch, either potato starch or corn flour starch, cassava starch, wheat starch. Okay. But here the concern is, see, for bacterial contamination, we have treated only 5 to 10 minutes. But for starch modification, we need to treat more time. So it takes at least 1 hour to modify the starch. So after modification, the starch has improved, the ozone has improved different functional properties of the starch. So it improved the dough strength, pasting profile, it improved the color. So this is another part. Here I'm just highlighting about ozone is also useful for stored product insect control. So if we are storing any grains in our houses, we might be observed within 1 month. There are different kind of insect pest that is present in our grains. Okay. So these are the common insect pest that is present in the grains like Cytophilus oryzae, Rhizobertha, and Tribolium castaneum. So generally in FCI gudowns, they are using phosphine or methyl bromide. Methyl bromide was already burned due to this ozone depleting nature. But phosphine, we are currently using phosphine. But the problem with phosphine is, once in 15 days interval, we have to continuously use this phosphine. And this phosphine have generated the residue on the surface of the grains. Okay. This is the same treatment setup. So in order to treat grains, we need oxygen concentrator, ozone generator, treatment chamber, analyzer, and ozone destructor. Okay, the same treatment setup. But in case of grains, we have to pass only gaseous ozone. Here we should not apply water-based ozone. So we have conducted the study and we understand that to control this Rhizobertha dominica, so we treated the grains from 500 to 1500 ppm of ozone. So as I mentioned, if your food produce have low moisture, example, you take any grains, it has a moisture content of 10 to 12%. Okay. So if have low moisture, even you can treat with ozone, higher ozone concentration, 1000 ppm. But in case of fruits and vegetables, it have higher moisture, 80% moisture, 85% moisture. Okay. That time you have to go for lower ozone concentration. So this is the observation we have made. Even you take the rice grain, you are treating with ozone, 1000 ppm, 1500 ppm. You see, if you are treating the grains at 1500 ppm of ozone, due to this high oxidation potential, the grains start cracks on the surface of the grains. Okay. That's why it is always recommended that we should not go for higher ozone concentration. Even we have tested with the green gram, it was found that ozone is very effective. And ozone is also useful for to control this aflatoxin. Okay? Because as per WHO, World Health Organization report, most of the grains, almost 25% of the grains what we are producing, it is getting lost due to this aflatoxin contamination. Okay. So this is the industrial scale setup. So here, once the grain is stored in the silo, they are passing this gas inside the grains to control this aflatoxin or stored product insect. Okay. So, but in case of aflatoxin control, we need to treat minimum 1 to 2 hours of time. Okay. So in case of fruits and vegetables, only 5 to 10 minutes. But in case of grains, we need more treatment time, minimum 2 hours, 1 hour, 2 hours, 3 hours. So as I mentioned, ozone is also effective for this virus control. Okay. So after this COVID-19, there are many research how this ozone is effective to control the virus, and it was proved that low ozone concentration, less than 1 microgram per liter, with the short contact time, less than 1 minute. So with the low ozone concentration, with low contact time or short contact time, we can able to inactivate 99% of the virus present in the producers. So any technology, if you want to establish at industrial scale level, the major factor is cost. So we have published a research work by analyzing cost estimation for the preservation of selected food or crop products with ozone. Okay. So we have taken 30 research papers or case studies, and we have calculated the cost. And this work was published in Journal of Food Process Engineering. And we found that if you use ozone to treat 1 kg of fruits and vegetables, we have to spend 0.86 paisa per kg of food produce. Okay. So far I have highlighted about how our ozone is advantage than other non-thermal method. This slide I am explaining about the disadvantages of ozone. So whatever experiment we are conducting, that should be the hermetically sealed condition. If you are passing gaseous ozone, the treatment chamber should be hermetically sealed. It should not be air leak. Okay? Because if the human being is exposed to the ozone gas is toxic to the human being. That's why the treatment chamber, it should be very closed, hermetically sealed. But if you go for this water-based ozone treatment, since your ozone is dissolved in the water, it need not compulsory to treat it under hermetically sealed condition. Okay. And also the concentration. If the human being is exposed to the higher ozone concentration, it will start irritating the eyes, throat pain, headache. Okay. That's why in many of the industries, in the wall, they will attach ozone detector. So if ozone leakage or if ozone detector, it will detect more than 0.5 ppm, immediately it will switch off this ozone generator. Okay. So these are the safety devices we have to attach with this ozone setup or ozone-based industries. Okay. So these are the reference I have used for preparing the slides, and even I have published more than 20 papers relevant to ozone. And every year, 16th of September, we will celebrate Ozone Day. Okay. So that's all about from my side. If you have any queries or clarification, you can ask.
Thank you, sir. Participants, please ask questions and clear your doubts. Please ask the questions.
Good afternoon, sir.
Good morning, sir.
One by one, you can please ask the question.
Good morning, sir. Myself from Dr. Sambat Kumar.
Yes, sir.
Yes, sir. So ozone is that is washing out of chemicals, especially in